Hey everyone, I am so delighted to welcome everyone to the first International Society for Applied Ethology, Africa and West Asia regional meeting. The region was created out of the former Australasia-Africa region in the year 2021. Since 2021, when the region was created, there has been a significant increase in membership, and we hope that you will be eager to join the society after this meeting. Exciting and insightful activities outlined in the meeting. We have 4 plenary talks and 10 oral presentations, and these oral presentations are really from early career researchers. The oral presentations were selected based on the criteria that they were related to the scope of ISAE, which is animal behavior and welfare. Just developing applied animal behavior in this region, we felt it would be great to include other activities such as talks on career opportunities in animal behavior and welfare, and how to publish in high-impact journals. There is a networking session which I want everybody to participate in because it is an opportunity for you to meet other ISA members from other regions and also to be able to learn from their research experience. ISA has a policy on equity, diversity, and inclusion, so there's no fear of discrimination. I hope you find this meeting worthwhile and your engagement will be highly appreciated. Thank you so much for joining wherever you are. And with this, I would like to invite the ISA president in person of Professor Mark Rutters to declare the meeting open by giving his opening remark.
Thank you very much for inviting me to open the first meeting of this new region. So it's really exciting that that we've got these developments in Africa. I see this is mainly I think your participants are joining mainly from Africa for this meeting, but it's really good to see that we have these sorts of activities. So just as a way of an introduction to the society, I'm going to tell you a little bit about myself very briefly, but then tell you a little bit about the history of the ISE, really talk a bit about our structure, talk a bit about what we're trying to achieve as a society, and then I will formally open your first meeting. So my name is Professor Mark Rutter, and I'm the president of the ICE. It's a 2-year post, so I will hand over to the junior vice president, who I believe is actually talking to you tomorrow. You've Janice Siegford, so I'll be handing over to Janice next summer is the plan. So I'm a professor of applied animal behavior. I've been working in the field of animal behavior for about 35 years now. I work at a small agricultural university in the county of Shropshire in the United Kingdom. So I'm not sure what your geography is like, but just to show you where I'm based. So we're sort of fairly central in the UK, and I'm looking out on a not too bad morning. I'm actually talking to you from home this morning as we are an hour behind, or an hour ahead. Anyway, it's just gone 8 o'clock here. So that's enough about me. What about the society? So the society has got a reasonably long history. We were founded in 1966, and it was originally founded by a group of vets that had this interest in animal behavior, and it was originally only open to vets, and they called the Society for Veterinary Ethology. Again, they had this focus on really trying to understand the sort of role of behavior in helping diagnose disease, but also understanding those complex interactions we've seen between health and behavior. Now, hopefully you already understand that the term ethology is really just a sort of technical term for the science of animal behavior. So it was a few years later that the first non-vets were admitted, and then the society even quite early on started to get some international interest, and they held their first meeting outside the United Kingdom. It was actually in Belgium in 1972. And then in 1992, at the Congress in Edinburgh, which I was actually at, the society decided it should change its name, drop the veterinary side, because obviously that requirement for vets had been dropped a long time earlier, to the International Society for Applied Ethology. So this very much recognized that it was a truly international society by that point, And we currently have approximately 650 members across 13 different regions. So this just shows the breakdown in the regions. So Africa and West Asia, you are at the moment our smallest region, but we're hoping to see growth in that region. I remember I was the membership secretary back in the 1990s. And at that time, there was this relatively small region called the USA. And as you can see, they've now become a very large region, our largest region. So we still have a sort of a fairly strong focus within Europe. So roughly half of our members are in Europe, but we've got members across 45 different countries around the world. And again, it's great to see this interest in Africa. So we have one of our main activities is our International Congress. So we hold this meeting once a year. So this year we had our meeting in North Macedonia, in Europe, in the Balkans. And we would normally alternate between meetings inside and outside Europe. But as a result of the pandemic, we've got a little bit out of step. So our next meeting will be in Estonia, which is also in Europe, in 2023. And then in 2024, we're planning to go back to Brazil. And again, Brazil was one of those small, part of a small region initially, and we've got lots of activity going on in South America. And hopefully, it won't be too long before we're hopefully coming to an international congress in Africa. So just to talk a little bit about what the society is aiming to achieve. Bear with me a moment whilst I just move this window. So the ICE really, it's about providing this forum for the sort of presentation and discussion of the science of applied animal behaviour. And we're also very keen to promote education in this area, because we recognise that it's a very important area really for sort of several aspects, in terms of not only finding ethical ways of treating our animals, but also finding ways of making sure that our production systems are efficient. If we can modify our systems to really accommodate the animal's natural behaviour, I believe we can make them a lot more efficient. And there are lots of other reasons really why we think we should be studying animal behaviour. And again, we achieve this really through two primary means. Firstly, we have the annual International Congress, but then what's also really important, we have this regional structure. We have the 13 separate regions, and it's the regional meetings, the one you're in now, that's actually also really important, because it's at these regional meetings that not only can the delegates from the region get together to discuss applied animal behaviour, but you can obviously do so in a context where you can consider how exactly it's going to best be applied to the conditions that you're finding within your region. So this is why these regional meetings are really important for us in terms of progressing the science of animal behaviour, the study of animal behaviour in this applied context. And we have our own journal in association with the published Elsevier, which is Applied Animal Behaviour Science. Oops, just let me, I skipped on 2 slides there. So again, I've already talked a little bit about why the study of applied animal behaviour is important. And it's really very much about understanding these interactions between humans and these other animals. And again, it's about not only understanding sort of animal welfare and trying to promote good ethical treatment of animals, but again, it's trying to make sure that wherever possible, we can have a very positive interactions with our animals. We can manage them in ways that are compatible with their behaviour, because not only will that be good for their welfare, but it should also be good in terms of producing good quality products from them hopefully in economically viable ways. So we work on really quite a very wide range of animals. There's clearly a strong focus on the domesticated species. So obviously the management and welfare of livestock that are used in our farming systems is important. But obviously animals play lots of other roles. They're very important as companion animals to humans. So quite a lot of our researchers are looking at really the ways that we interact with our companion animals. And obviously, some of our some of our wild animals are kept in captivity as part of sort of breeding programs, as part of nature conservation programs, and they're kept in zoos. And also animals are used for various purposes within laboratories. So again, we have researchers with an interest in really understanding the behaviour and welfare of the animals in these sorts of environments. And then we also provide a pool of independent experts. So the society is recognised as the leading society in the world in terms of the study of applied animal behaviour. And we have experts who are contributing to governments, to various international bodies, to industries, to these non-governmental organisations and charities, in terms of, again, making sure that the science that our members are doing, the other science that's been done around applied animal behaviour, that science has been taken into account when decisions are made, really about whether it's animal legislation or whether it's about developing ways that, again, that we can ensure that we have this very positive interactions with the animals that we live with and that we manage. So for further information, I encourage you to go and have a look at the website, which is www.appliedethology.org. So again, very exciting that this is the first meeting within the Africa and West Asia region. It's again very important to us that we're very keen to have this international spread. We're very keen that the science of applied ethology is something that's being considered around the world, but we're very keen to hear your contributions, because obviously you have different conditions within Africa, within West Asia, and there will be different interactions. We will get different results to some extent from studies that are carried out within your region. So we're really very keen that you're not only carrying out that work, but that you're sharing it really with the rest of the international community. And it's really great to see within this program that's been organized that there are some discussions around careers. I think this is a very exciting time in terms of looking for the future, about developing ways that we can manage our animals and the planet more sustainably. And I think applied animal behaviour has a role to play there. And as I mentioned earlier, it's also important that the work you're doing is published around the world. And we're very keen to really try and make sure that we can get your work published in the sort of top journals, so that your message is actually being shared around the world. And again, it's fantastic the work that CERN's doing in terms of really helping drive this region. To some extent, the regions, it's really important to have a very good dynamic regional secretary, and I'm very happy that we have that for this region. So without any further ado, I'm absolutely delighted and honoured to be able to open the first regional meeting of the International Society of Applied Ethology. And again, I really do wish you a very successful meeting. Unfortunately, I can't join you. I have quite a busy day of teaching today, but I'm hoping I might be able to dip in a little bit later on. Anyway, so enough from me. I'll hand back over to CERN, and best wishes for hopefully a really good meeting.
Thank you so much, Mark, for that wonderful introduction about the society. And thank you for introducing me. I think I forgot to introduce myself because of the excitement. So I think I'll do that properly now. I am Dr. Iyasiri Oluwaseun-Sarah. I am the Regional Secretary for the Africa and West Asia region. I am a senior lecturer at the Department of Animal Physiology, Federal University of Agriculture, Abeokuta. And currently, I am a George Foster Fellow at the Humboldt University in Berlin. So I want to appreciate Mark for declaring our meeting open today. And I wish all the participants will stay through and benefit from all the activities that we have outlined for them. Thank you so much, Mark. With that, I would like to take, we'll be going into the first plenary talk. This talk will be given by Dr. Mount Bonato. She's also an ISA member in the region. Mount Bonato studied animal biology in France between 1996 and 2000. And in South Africa, where she completed a PhD on the mate choice and immunocompetence in ostriches at Stellenbosch University in 2009. She carried out a 5-year postdoctoral fellowship to assist in the development of an artificial insemination program for the ostrich industry. She was subsequently appointed as a research fellow between 2014 and 2017, as an exemplary lecturer and researcher between 2017 till date, and to pursue this project. In addition, she conducted and promoted research in animal behavior and welfare in farm and captive species. In June 2020, she was appointed as the head of the research at the Elephant Park to conduct similar research in captive populations of elephants. Her research interest has thus been on the crossroad of animal behavior, immunology, reproductive physiology, and animal welfare. She uses this multidisciplinary research approach to understand how temperament, genetics, and life history experience affect the ways in which captive and farm animals perceive and respond to their environment. Ultimately, she intends to further elevate and expand the broader impact of animal behavior and welfare in production systems, as well as in the rising number of breeding programs from endangered species. So permit me to welcome our first plenary speaker for today, Dr. Mount Bonato. You're welcome, please.
Good morning, everyone. Thank you very much for the introduction. I'm very, very pleased to be able to share some of my experience with, I think, a bird that everybody knows, but don't know much about. I mean, this is a bird that you will see in the African savanna or on farms, but I always get a lot of inquiry about why do you want to work with ostriches. And I'm just going to share my screen now, so then we can get started with this presentation, and to show you a little bit why I have spent 17 years of my life and going strong studying them. So, as I mentioned earlier, this is trying to sum up 17 years of research. Most of that research has been involving different kind of field with different kind of people, but I will acknowledge. I would like to acknowledge at the end of this talk. But all of that was basically to try to understand a little bit more about the behavior in captive settings, and all of that to improve their welfare and ultimately their reproduction. So ostrich farming is a relatively spring chicken industry, especially when you compare it to other livestock species that have been domesticated for about 100, if not thousands of years. It originally started in the mid-1800s in South Africa, in a small little town called Ostrich, which is located in the Little Karoo in the Western Cape region of South Africa. They were originally farmed for feathers, and until the collapse of the feather trade just after the outbreak of the First World War. And the farmers had to basically try to find a way to make their enterprise still valuable. So this is where they started looking at other products, and they started developing a system where they were producing meat and leathers. And that has become, since then, the major products that come out of ostriches, at about 45% each of the outcome of ostrich farmers, and with feathers only contributing to an additional 10%. So as a result, we had a much shorter period of domestication. And this might explain why they are still relatively wild and aggressive birds. And of course, this has consequences on their welfare during all phases of the production system, starting as early as the hatchery stage with high embryo mortality and high hatching failure. For instance, hatchability is typically between 30% to 60%, but can be as low as 11%. But also issues at the rearing stage, with mortality varying between 0 to 100%, especially during the first 3 months after hatching. This is basically the red zone for ostrich farmers that are raising chicks. And just to give you an idea, it is generally accepted that a good ostrich chick season corresponds to about 30% of the chicks surviving to about 10 to 12 months of age, which correspond to the slaughter age. And there is also highly variable growth rates. This is the picture that is here on the slide is a typical example of chicks having the exact same age, same breeds, but you can see how some of them are much bigger than others. And that really create problems because the small chicks usually really struggle to survive amongst those bigger chicks. But welfare issues are also observed at the flock level, with mate incompatibility specifically when birds are maintaining pairs, resulting with high infertility rates. And the typical aggressive behavior of males is also known to compromise not only the occupational health and safety of the workers, but also the birds' welfare. Recently, the ostrich farming industry has been under a lot of scrutiny from animal rights activists, but also by big European companies that are the main buyers of ostrich products. France is one of them, Brazil is one of them. And these companies are under continued pressure of their clients who demand more guarantees that ostrich products are produced in a sustainable and ethical way. Hence the need to actually focus specifically on improving ostrich welfare. So the aim of this review will therefore focus on the new development in improving ostrich welfare at the rearing phase. So that will involve chicks and juveniles, as well as the breeding phase. Then I will conclude on the road ahead for research scientists like me that are still involved very much with ostrich research, but also try to understand what would be practical for farmers to implement to make the system a little bit more viable, financially viable. So starting with the beginning, the rearing phase. It is commonly known that daily inspection, gentle handling, extensive human presence are all shown to improve welfare and production in various livestock species. But what about in ostriches? So the question we ask ourselves is whether extensive human presence could actually influence critical parameters in ostrich chicks' development. And to answer these questions, we submitted groups of chicks to 3 different treatments. The chicks that were raised using the HP1 treatment were basically familiarized with extended human presence over a period of 3 months of time. So that's basically trying to cover that danger zone for ostrich chicks. So the first week, they were exposed to human presence 100% of daylight, because at night they do go to sleep. And then every week, we decrease the human presence by 50% until we reach 3 months of age. These chicks were also familiarized with gentle touch and also to a voice, never shouting at them, always being very calm with them. The HP2 treatment was similar, so we also extensive human presence to the same kind of frequency and intensity. They were familiarized with our voice, but we were not touching them. And finally, the standard group was basically raised using the standard husbandry practice of the farm, which is simply giving them food and water several times per day, no other contact with the chicks. And we looked at the effect of this treatment on critical parameters for ostrich chicks. First of all, the weight and survival at 6 weeks. So usually chicks are fine up to 4 months of age. And after 4 months of age, and specifically between 4 and 6, this is where they start getting sick and they die in number. Then we looked at the effect of this treatment on immune responses when we had to vaccinate them against Newcastle disease vaccination at 20 weeks. Then we looked at the stress responses when they had to undergo feather harvesting, which we believe is actually something that is stressful for them. And at 40 weeks, we looked at the behavior of these birds towards their handlers. And finally, we wanted to know what effect what we do early with them when they start their life on their reproduction performance when they reach sexual maturity at 2 years of age. So the first thing that we looked at was the effect on this treatment on early growth and survival. And that was clear is that the chicks that were exposed to extensive human presence gain a better weight at 6 weeks old than the ones that were not as much exposed to humans. But they also survived better. And that tendency was even better for the HP1 chicks. They had higher weight gain and they survived better than the other groups of chicks. Now looking at the immune response, again, something that we were expecting, but we were not expecting such a difference between both groups. Yet again, the chicks that were exposed to the HP1 treatment, extensive human presence, voice, touch, they actually managed to raise a higher immune response than the other two groups. Now, looking at the short-term stress responses, so what we did is that we specifically focused, like I said, on the feather harvesting. So there's two methods in the ostrich industry. They either are being plucked while they are alive, or they are being clipped. So obviously we thought that the plucking procedure might be more stressful to them than the feather clipping. So we made some blood smears before the treatment and 72 hours later, because this is where it has been demonstrated that the heterophile lymphocyte ratio will be the highest. And interestingly, the HP1 HP1 chicks were basically unaffected by either method. But that was not the case for the HP2 and the standard chicks that experienced both this management method as stressful. So yet again, we managed to reduce the short-term stress response in the HP1 chicks. Now, of course, the chronic stress responses are also very important. So the way we assessed it is by measuring the corticosterone levels in the floss feathers. And yet again, the HP1 chicks had much lower corticosterone concentration in their feathers than the rest of the chicks. So we also managed to reduce long-term stress responses in those chicks. Now, going back in time, before this specific experiment, we did some preliminary work where we also exposed those chicks to extensive human presence, but for a much shorter period of time. It was just for 30 days. So on this graph, they are referred as imprinting 1 and imprinting 2. Standard groups are the same as in the previous experiment, exposed to the normal husbandry practice of the farm. And then the foster group, those chicks were raised by foster parents with almost no human contact whatsoever. And we looked at the response of those birds towards observers. And again, you could see that the chicks that were exposed to some degree of human presence were more inclined to associate with the observer than, for instance, the foster chicks. And they were also more inclined to let you touch them than the foster chicks. So all in all, the chicks that were exposed to human presence were more inclined to associate with humans. They were not as afraid as chicks that were not exposed to humans. So we repeated something similar for HP1 and HP2 chicks, just to look at whether their behavior will change if they are exposed to someone they know and someone that they don't know. And what was really striking is that they were more willing to approach someone that they were familiar with as compared to someone that was not familiar with. And we recorded another behavior. So the wing flapping is something that ostriches would typically do when they are a little bit unsettled. They are a little bit anxious about an element that is part of their environment. And the chicks that were exposed to unfamiliar human were actually a little bit more wary by the number of wing flapping they were displaying towards the unfamiliar person rather than a familiar person. So they were not only more inclined to associate with a familiar handler, but they can also, what it shows is that they can discriminate between people and adjust their behavior accordingly, which in the case of ostrich farming that can be very hands-on is very important, because by using people they know and they trust, it might facilitate the whole handling procedure. So now, to conclude the life cycle of farm ostriches, we needed to make sure that whatever we did with the chicks at an early age will not compromise their reproductive performance. And for a long time, it was commonly accepted that chicks that were habituated to humans will not be able to reproduce because they would redirect their sexual display towards the humans. But when we looked at the egg production and the chick production of those chicks, specifically the HP1 group against the standard group, you could see that they were that had no effect whatsoever on the egg production and chick production. And I would say even better than that, they seem to actually do better than the ones that were not exposed to human presence. But unfortunately, we didn't have high numbers of duplicates to be able to have a very, very significant experiment. So this is something that we still need to redo and just check that the results we have actually significant. Also, and that came out from a complete different experiment that I will present a little bit later. When we're selecting for birds that are relatively docile, we thought maybe there's a role for genetic selection for good temperament. So we looked at the heritability estimates for behavioral traits that we believe are actually positive when it comes to the human-bird interaction. And what we found is that the heritability estimates, for instance, of approach, touch, and distance were actually relatively high, which means that it could be possible to select for good behavior. And that is quite important as well, because that means we might be able, through genetic selection, to speed track the processes of domestication in this species. So that concludes more or less the rearing phase of animals. Now moving on to the breeding phase, which is just as challenging as the rearing phase, but in different ways. It became clear to us that a better understanding of ostrich flock and ostrich reproductive behavior was needed. In particular, what is the effect of mating preferences? We know that in the wild, those animals, those birds, are promiscuous. They have multiple partners for males and for females, for that matter. Also, what about the group structure and composition? And finally, is there a role for assisted reproduction like it has been implemented for other species? So when it comes to ostrich farms, farmers usually use two systems. They either use pairs, so one male, one female, or they use flocks, where they have, it can be 50 birds, it can be 100 birds, it can even be more than 1,000 birds, all into a very large camp. But there are pros and cons to these two methods. For the pairmetic system, obviously it's easy to measure reproduction, it's easy to record pedigree, and you can easily do genetic selection. However, there are issues with mating incompatibility, and that results in a highly variable reproduction. It's not because you're going to put a male and a female together that they're going to get along with each other. And often, what is observed in on farm is that the farmers, if they see there's a combination that's working, they're going to stay together for a long time. So you are confounding the random effect, and you have not a clear picture of what's going on. It's also obviously a very narrow female male to female ratio, and the good birds will actually not be able to spread.
Rising can say 1,200. A 800.
And there's
including
also sorry, you guys.
I'll come to answer.
Sorry, please. Who is that? Kindly unmute, please. Who is disturbing? Hold on, please. Sorry. Just hold on.
It's all right. Don't worry. Just
hold on a bit. I'll try to sort it out.
There's also a risk associated with aggressive males, and that is very specific for that system, because if the female doesn't want to mate with that specific male, some will actually kill the female. So obviously that has an influence on the welfare of that specific female. For the flock camps, obviously it's less labor intensive, because you just put those birds and then you pick up the eggs, and it's much easier than maintaining all these small camps for two birds. It also allows natural mate choice and reduce infertility. You give more natural settings to the birds. But in terms of cons, you have no individual measures of production. The technology is not that, well, it is there, but it's too expensive to be able to know where those chicks that are being produced come from. So the genetic selection is very difficult, if not possible. Obviously, we know that this system is also inefficient due to what we call the freeloaders. Some birds are just not contributing to the system because they are being suppressed by other bears. But the farmer's team needs to take care of them, and whether it be for food, supplements, vaccination, vitamins, whatever. And also when you enter those big flocks, ostrich males are very territorial. So if you enter to pick up the eggs, there is a high chance they will come for you, and they can be quite dangerous. So again, this is dangerous for the humans, but that's also dangerous for the birds. So we started from the beginning and looked at what is actually happening in ostrich flocks. And this was in fact part of my doctorate a couple of years ago. And what we demonstrated is that there is actually active mate choice, meaning that specific combination of parents will significantly produce more chicks than others. And others, as you can see, they are pairs that, for instance, here M19 that produce very little chicks. So this is something that we need to take into consideration when breeding ostriches for chicks and egg, or egg and chicks. Then we moved on and manipulated the size of these groups with 1 male, 2 males, and 3 females that were paired with 1 female only, or 3 females, or 4 females. And we were expecting that the reproductive success would increase with the number of birds in those camps. So what we actually observe is that the number of eggs and subsequently the number of chicks produced actually decreased as the number of males increased. However, when we look on the female side, the number of eggs and chicks produced remain relatively stable as the number of females in groups increase. So what this simply means is that competition of males over access to females might actually compromise the production performance. So the next step was to look at the effect of group composition on production performance by manipulating male and female relatedness in those groups. And why this is important? Because this is a problem that ostrich farmers are dealing with. They know they have related birds. So how does that affect the reproductive cycle? So we had groups with 2 males. Some of them were unrelated, and the other was full brothers. And other groups with 3 males where they were either unrelated or related, or a mix of the two. And what we found is that the number of eggs produced were higher when males were related, and somehow compromised where the 2 males were related and one of them was not, which means that related males in flocks would tend to dominate reproduction. So we did the same thing with females, where we had groups of 3 females all related, and with 2 related and 1 unrelated, and then half-half. So what we found is, interestingly, is that egg and chick production seems to be promoted with a mix of related and unrelated females were present. So quite something different from the male strategical point. So this complicates things even a little bit more. So obviously we wanted to understand, why are we observing this? So we looked at harassment, which is something that is happening in ostrich flocks. And what we saw is that if you had the number of harassment of females would actually increase with the number of males, but even more so if those males were unrelated. So for an ostrich farmer, if he had to use more than 1 male in his flocks, it would be better if these males would be brothers than unrelated. However, when it comes to the females, that was the opposite trend. And it seems like the optimal number of females would be maybe 3 or 4 per male, maybe more, that we haven't tested yet, but they need to be all unrelated. Because female also fight. It's not just the males. The female also fight for a number of things when they are in those camps. So all of this needs to be taken into consideration. Obviously, it's good in theory. Practically, it's a little bit more complicated, but this needs to be thought through when you are putting those birds in those camps. Now, an alternative to this current METIS system will be to try to develop and implement assisted reproduction in this species, as it is founded on sound knowledge of ostrich behavior and reproductive physiology. But one would ask himself, why would you like to develop artificial insemination in such a difficult species? Fair question. Well, the idea would be to be just like in the cattle industry, to farm without males, and that will have several benefits. First, fewer birds to feed because you only select the good ones. So at the same time, you put more selection pressure on the males. Obviously, and this is something that you will see on the next slide, is that we need to work with birds that are relatively docile. So if you take that aggressiveness of the males out, you might be able to improve the occupational health and safety of the workers, but also the welfare of the birds. Obviously, this is not a straightforward plan, and there are prerequisites to be able to implement such a technology. You need to be able to collect good quality semen. That was a major hurdle because the manual massage was not efficient. It put a lot of stress on the animals, and the quality of the ejaculation was really bad. The next step is to be able to have females that can lay eggs without males. And once you have that, you need to be able to inseminate those females in a stress-free manner. Also, obviously, you need to be able to have diluents that would preserve the integrity and the function and the functionality of sperm, ostrich sperm. So that needed to be also put in place. And finally, how much do you need to inseminate those females, and how often, to promote fertility? So in the late 2000s, a new method to collect semen was made available by some Polish colleagues of ours, of all places. They developed the dummy female method, which basically rely on the complete cooperation of the males. So this is a demonstration. So basically, we select the males based on their response to us, and we train them to mount this big bag. So you see now the bird is going to show the typical mating behavior, the stepping. So it will do the same thing for a female, right? Before sitting on it. So we are pushing that dummy female with basically just a wooden structure filled with foam, and we try to shape it like the body of a female. Inside that big bag, there is we put a PVC tube with latex liners that are used for also semen collection. We fill it with water just to mimic the body temperature of the ostrich female. And at the end of those liners, we have a semen collector. So as you saw on that video, the handler actually pulled gently the bird on the male and tried to get him to sit correctly. Now you can see the wing flapping has increased quite drastically. This is when we know that the semen collection was successful. When you're sitting there, you don't see anything. It's just feathers and dust. But what is quite striking is the trust relationship between the bird. Remember, this is an ostrich male, and the handler. So the whole procedure usually takes a bit less than a minute. We take more time to prepare everything than actually doing the semen collection. The training period is very, very variable between males. Some of them can get what is supposed to do very quickly, others it might take a little bit longer. So this is how we do semen collection. So once we collect it, we measure obviously the seabed that we collected, and on average, ostrich ejaculate is about 1.5 milliliter. It contains 3 billion sperm, of which are 75% abnormal, 15% are abnormal, and 10% are dead. But what we know is that we can actually collect semen relatively frequently, at least twice per day for a long period of time, without either depleting the sperm reserve or affecting the male libido. What we also know now is that we can collect all year long. Obviously, there are periods of time where the libido of the males might not be on top, or even the quality of the semen is not fantastic. So when we want to go for good quality semen, it will be towards late spring and until midsummer. So come September, October, November. So this is quite important to know, because you want, especially if you want to freeze the semen, you need to know when is the best time to actually go and collect. Now, the second step was to have a flock of females that can actually lay without males with them. And for a long time, ostrich females were considered as induced breeders, meaning that they will not be able to produce eggs if a male is not present. So this is a fundamental part of AI technology. If you don't have that, then you cannot move forward. So what we did is that we single pen female, and when we looked at the production pattern over a couple of years. And what we saw is that they can actually produce eggs without a male. Fair enough, they do not produce as much as when they are paired with a male. And also what is quite striking for us is that they follow the same laying pattern that if they were paired with a male or in a flock. The peak productions arrives towards the end of winter in South Africa, which is from July, August, and then it relatively stabilizes up to December, January. They can carry on until March, April, and this is where they usually drop and take a bit of a rest. So now we have our eggs. We need to be able to inseminate those females. The problem with ostriches, as aggressive as they can also stress really quickly. So inseminating a female by constraining them is just a no-go. She will stress so much, she will stop laying. So again, our colleagues from Poland develop a new method that is animal and user-friendly, in the sense that, again, that bird is cooperating with us to the full extent. So the selection is quite important. You have to make sure that that bird is not aggressive towards you. And bit by bit, you build a relationship with them. And we use what is called the voluntarily crouching behavior. So this is me a couple of years ago going to inseminate that female. So you see, she's already sitting for me. That's what she will do for a male, and she's clacking. So she's making that little sound with a beak, basically waiting for me. This is a very tame female, because sometimes you need to have an additional person to sit on the top of the female. So you see, she's a little bit wary, not because of me, but because there is that person that is filming her and she doesn't know that person. But what we do is usually we make sure that she is comfortable. We don't hesitate to pat them before we do anything until that bird relaxes. And then we introduce the insemination straw inside the cloaca, trying to push it as far as possible into the vagina. You can see she's a bit wary. So again, I'm stroking her a little bit, and then she relaxes, and then I can introduce gently the insemination straw a little bit further. So with some birds, again, just like males, there's a lot of variation between birds in the way they react to us. Some of them, we're going to be able to inseminate them straight up. Others might take a little bit longer. But you can see the trust relationship goes both ways. And that female was actually quite happy to see me, as much as an ostrich can be happy, I guess. So now we have managed to inseminate those females. The next step is to check whether this insemination was successful. So we use what we call the egg breakout technique. So we open up all the eggs after the insemination, and by looking at the structure of the germinal disc with the naked eye, we can know whether the fertilization was successful or not. So this is an example of an egg that was not fertilized versus an egg that was fertilized. You can clearly see the difference of structure. We have rings that are around the germinal disc. So we know that the insemination was successful. But better than that, we can visualize the sperm on the membrane using a fluorescent dye. And that allows us to actually know how many sperm reach the germinal disc, but also looking over time, what is the rate of sperm loss. Ostriches, like any bird, can store semen in a specific structure that are called sperm storage tubules. So then that will allow us also to determine how much we need to inseminate them and how frequently. So very important piece of information. So we have all of that in place. Now the problem with avian sperm specifically, and ostrich sperm is no exception, is that if left undiluted, it coagulates rapidly. So that means the quality and viability is going to be compromised over time. So we needed to develop a semen diluent for survival in vitro, but also for AI purposes. And we did that by trying to develop a diluent that is specific to ostrich sperm to maximize survival. So the first step we did is that we compared it with the EK diluent, who has been used and developed for other avian species. And what we saw is that with our diluents, we actually had the same percentage of fertilized eggs. But the important piece of information here is that the fertile period, or in other words, how long the female could lay fertilized eggs using those diluents, was longer for the ostrich diluent. And obviously, this is what we want to achieve. And when we looked at the number of sperm that were trapped in the egg, again, there were higher number of sperm trapped in the egg with the ostrich diluent rather than the EK diluent. That's probably why we had fertilized egg for longer. So when it comes to storage, we stored up to 24 hours. So that would be, for instance, for keeping semen, and that needs to be shipped somewhere else, but it's relatively close from where we collect it. And we did not observe any decline in sperm motility and viability up to 24 hours. For long-term storage or cryopreservation, we observed a reduction of sperm motility and viability by 50%. But knowing that it's quite a stressful process for sperm, it's actually not relatively good results for that matter. It still needs to be optimized, but this is a good starting point. And we did obtain fertilized eggs after AI with sperm stored for 24 hours and cryopreserved. But like I said, there's still room for improvement for both protocols. And that might involve having slightly adjusting the ostrich diluent for cryopreservation, which we have done, but it's still not optimized. So, final step, we need to be able to determine the dose and the frequency of insemination to make it practical and viable. So what we did is that we inseminated those females with different doses of semen, anything from below 2.5 billion to higher than 7.5 billion. And we obtained overall mean fertility of 35%, and we observed an effect of sperm dose on fertility rate after insemination. So what this graph shows is that below 2.5 billion, this is not enough. But when we reach the dose B, which is anything from 2.5 to 5 billion, we managed to stabilize fertility. So what we have achieved is that we know that with a dose of 2.5 billion, we have managed to fill up the sperm storage tubules. So that's enough to fertilize eggs. Anything more than that would actually be a waste. So we actually have managed to pinpoint what is the dose that would actually work for ostriches. So next step was to look at the frequency of insemination. And for that purpose, we inseminated for 2 consecutive days using the dose of 2.5 billion. And then we repeated single insemination every week for 4 weeks. And we had a mean fertility of almost 39%. And again, we observed an effect of insemination week on fertility. And it looks like from week 3, we basically managed to stabilize the fertility rate. And you see, as soon as we stopped doing the weekly insemination, the fertility rate decreased. So at this point, what we can do, but that could also be optimized even further if we make the ostrich diagram even more efficient. Two insemination as a start, and then a weekly insemination will allow for to maintain fertility rates. So based on this result, is there a role for assisted reproduction? I believe there is, but we still need to have an indication of what will be the best sperm dose and AI frequency when we're using chilled and frozen thawed semen, because obviously not all ostrich farm will be right next to where we are doing our experiment or collection. Also, the timing of insemination, should we inseminate before or after oviposition? So far, we have chosen to do after oviposition, simply because the females tend to not want to sit down if they are about to lay. So ostriches usually lay early mornings. That can be very early during summertime. So we can actually go at about 7 or 8 in the morning and they are ready to go. Some of us might lay later in the afternoon, but that's more the exception than the rules. We also need to try to synchronize egg laying, because at this stage, every single female starts laying at a different time. So this is not necessarily super practical. When you start inseminating one female, you'd like to start inseminating more than one. So this is where we need to know how we could synchronize all these females to start laying. Also, we need to compare the economic benefits of this method compared to natural baiting. Is it worth it financially? And also, as you can see, there's a little bit of training involved on both parts, from the birds, but also from the handlers. So to conclude, going forward, it is clear that the management practices currently in place would benefit from adopting a more hands-on and positive approach when rearing ostrich chicks. And this is something that we have seen in, I would say, more modern ostrich farming, where some people are actually spending more time with them. And the results are striking. The chicks look healthier, they are bigger, they survive better. So this is something that really needs to be implemented. I know this is not necessarily practical for many farmers that have lots and lots of chicks, but it definitely shows some good results. We need to have an even better understanding of the behavioral and physiological needs of ostriches. So there's still a lot of work to be done on that matter. Considering assisted reproduction as a viable alternative to current production system has the potential to alleviate the incompatibility between mating partners. Now it's just the compatibility between the bird and the handler, and also try to alleviate low fertility issues that we observe in ostrich flocks. As you saw, those animals are quite tame, quite docile. I've worked with them for 17 years. I've never been kicked once. So that will definitely help with the occupational health and safety of the workers working with more, I would say, chilled animals. There are always injuries at work when it comes to managing ostriches. This is unfortunately part of the job. They are quick, they are powerful, and that can also, ends up very badly for the workers. So we're trying to select for animals that are easy to handle, that actually improve that. Obviously, ostriches that will improve ostrich welfare. Ostriches, when they stress, they do stupid things, and one of the main thing is to run into fences. So if they can injure themselves, they can kill themselves. But if those animals are used to the normal routine of the farm, they tend to be a bit more chilled when the people are coming to pick up the eggs or for routine maintenance procedure. And that's what we would like to see, that more animals that are chilled and not stressing anything new in the environment happens. And that obviously could be achieved by selecting specifically for good temperament. So there's definitely also a need to focus on assessing different levels of ostrich welfare at the current production levels. And what about doing a welfare assessment protocol specific to ostriches? We have started with that. We're a bit short of hand at the moment, but this is something that is needed. What what are the husbandry practices that will make the life of ostriches slightly better? Enrichment is one of them. We have worked on that, on food enrichment. We have also tried to work on music enrichment, but this is just at the beginning. Also, we need to look at the cost of implementing animal-friendly husbandry practices and to check whether this is financially viable to move towards something that is more animal welfare friendly. And we have to think quick if the ostrich industry wants to stay competitive as compared to other farming industry. And on that note, I haven't done that job all by myself, so I would like to acknowledge all the people that participated over the years in this quite challenging enterprise. So it was a collaboration mainly between Stellenbosch University, the Western Cape government that gave us access to those birds, to the resource flocks, Lund University, and the University of Glasgow. And I thank you all for your attention, and I hope I triggered some interest in ostrich farming. Thank you.
Thank you so much, Mount, for that wonderful presentation. Actually, this is my first time listening to a presentation on ostrich behavior and welfare, and
oh, really?
I
Okay.
really found it sincerely interesting. Please, for the participants, kindly drop your questions in the chat box and we can take, we still have like 30 minutes or so to do Q&A. Please kindly drop your questions in the chat box. I have loads of questions for you here. And if you think you prefer to speak, ask your question, then indicate by the use of raise of hand, then I will unmute you and you can ask your question, whichever way you prefer. So, I want to believe most of the ostrich experiment you did was in South Africa. Yeah. So I also want to know, what is the ostrich industry like in other African countries? Do you have an idea? Because for me, I don't really have any clue about what it is like in Nigeria, though I've only seen ostriches in the zoo, maybe just one or two of them. I don't know of what the ostrich industry looks like. So do you have an overview of what it looks like in Africa or in West Asia?
Essentially, there used to be quite a lot of ostrich farms in Zimbabwe, but I'm talking about 20 years ago. And I think all the neighboring countries, but never to the same extent that South Africa. I mean, South Africa really has kind of the monopoly of ostrich farms. But the second country in terms of the number of breeding birds is actually in Iran, where they have about 400 ostrich farms. So they're right behind us. There used to be also ostrich farms in Europe, but again, a long time ago. And I think they basically failed. And this is because the weather is obviously, if you farm in the UK with lots of rain, this is not something they thrive in. So I'm not sure if there's many farms left since then. There used to be some in France, in Italy, Spain. There's also a market in the US. I often see some news feed about people wanting to sell ostriches. So it's still much lower than what it used to be in the past. And I think bird flu was also to blame. That has a huge, huge dent on the ostrich South African market as well. Lots of farmers decided, no, this is not worth it, because at that stage, the first outbreak, a big outbreak, was in 2011, and lots of birds were killed, which I don't think was necessarily the way to go about it when it comes to ostriches. But this is what they did, I think a bit out of fear that it will spread to the chicken industry, because ostriches do not get sick from bird flu. The virus just gets in, but then it mutates and gets transferred, and that's the problem. So there was room for more research to try to understand why ostriches are so resistant to bird flu, provided they are in good condition, obviously. So yeah, even the one in South Africa, even Ostrich, that used to be the capital, lots of people have decided to move on, unfortunately.
Yeah. Oh, that's interesting to know. So you also mentioned during your talk that between the 4th to the 6th week of age, that is the time when there's a high level of mortality. What could be the reason for that? Do these birds, do they cluster together like smothering, or what is exactly the issue between that time period?
I think this is where whatever is passed on by the mothers in terms of immune responses basically wears off. So up until, and it's really striking because we never really have any major issues up to four months, and past 4 months, this is where if there's anything in the environment, then they start dying. And when you see that happening, you know, okay, now we're in trouble. And I think this is the moment where whatever they get from their mother and their ability to actually raise their own immune responses is very important. So if there's anything that is changing in terms of the food, the routine, that will even make things worse for them. So that's why we really had to look after them very closely. And I mean, the percentage for us, we never had percentage of survival that high ever. I mean, we were almost close to 90%. And that is really remarkable. I wasn't expecting that we would survive so much. But I think that's the problem with ostrich farmers. They just leave them. So we usually maintain in big camps a bit. It's about 50 to 100 chicks when they're small, and then they get divided as they grow bigger because they grow quite fast. But yeah, so this is any changes in their husbandry up to a point is quite stressful for them, and that can actually create a lot of problems.
So is it between the 4th to the 6th week or month?
Yeah,
week.
4 to 6 weeks, yes.
Week.
But that is really, I would say, the dark red zone, right? So once you move that, it's still red, but you can relax a little bit. But those transition between, I would say, being really small chicks and bigger chicks is where anything can happen. And I've seen things that were really heartbreaking because we don't know what's going on and why they are dying. But it can be quite distressful.
Yeah, thank you so much. There is a question from Samuel Durosharo. He wants to know if there is any genetic effort to conserve the ostrich germplasm in Africa.
We're working on it. I think at this point, we still need to have someone that will try to really optimize the freezing process of ostrich sperm, but that is the idea in the future. And this is very important for many aspects. And one of them is bird flu, because back in 2011, when they were killing all these animals, our fear was that our farm will be also affected. And then we lose, this farm has been going on for 50 years, right? So that means all this effort, money, and expertise would have been gone in just a week. So I think the AI project is also looking at those aspects, trying to, you know, preserve what we have. And there are lines of birds that have been specifically bred for feathers, for instance. And we don't have that on the farm I'm working, but it's the kind of feathers that have been exported to specifically France or Brazil, when you have these costumes with these beautiful feathers. And that can only be found in South Africa. So it's quite important that we preserve these gene pools. So hopefully we get a protocol that is 100%, and then we can preserve those germplasm.
Wow, that is great. Thank you. There is a question here from Oluwatosin Enitan Shobi. Is ostrich meat healthier than other types of meat? It is.
It is, because it's got a very low fat content. And I'm not saying that because I'm in the industry. It is a healthier meat. It tastes like beef, but it's because it has very low fat content. It cannot be overcooked. Otherwise, you might just as well eat the sole of your shoe. It's really not good. So yeah, it needs to be cooked pink maximum. Otherwise, it's not good. But yeah, and it's much healthier. Yes, and that's what is I would say, the marketing key of selling ostrich meat, for that matter.
Yeah, thank you. In the first experiment, you reported about extensive human presence. I was wondering, can you describe that a little bit further? What do you mean by extensive?
We spent basically from the moment the sun rise until it went down, there was someone with those chicks sitting with them. And I see you can see it on those pictures with someone sitting there. So there was always someone that was wearing kind of the same outfit as well, so that, you know, they can recognize us. And so we, for 1 week, was 100% of the time daylight. And then we tried to habituate them of not seeing us all the time. So we decreased by 50%. So we had to, basically, we had a schedule, and we were looking, okay, so for these few hours, someone will be there, and then no one will be there. And we tried to stimulate them to eat and to drink, basically interacting with them as much as we could. For the second group, when we were not touching, we were doing the same thing, but preventing from touching those chicks. Just being there, just talking to them gently, and that's what we did with them.
Yeah. So I was wondering if you said in your presentation that the ostrich, they are able to identify familiar faces, and when they see somebody that is familiar, they're like happy, and they show this kind of distress behavior when they are in the presence of somebody that is not familiar with them. But I want to ask, how can one try to train the ostrich not to respond or not to show any form of anxiety-like behavior when they see unfamiliar faces, especially those that are kept in the zoo, and a lot of visitors come to to see them? What is the process like in trying to let them feel free with everybody and not be agitated when they see an unfamiliar face?
I think in our case it's more a matter because at some stage you're going to have to interact closely with them and you're going to have to move them around. And I mean, ostriches that are in a zoo, they are not there to produce, right? They're just here for the display. And I think people are not coming that close to them. So they have the choice to come closer or not. In our case, we are invading this space. We're going to get their eggs, we're going to fix the fence, we're going to do things. So it's better for them to know that, establish a trust relationship between the two. And I'm not saying it's not possible over time with the zookeepers. I mean, I think it's true for any animals. If you treat them right, they will actually build bit by bit a relationship of trust. And I mean, I've seen it so many times, even they have preferences for people. Why? I don't know, because I went for insemination. I trained my students to do insemination, and some females would just not sit for it. I had to be there. Why? I don't know. And he was just as gentle as I was, but no, she was responding to me. So that is a bit impractical, because if I'm not there, what is he going to do? But I think this really shows, for me, it was more a question of, ostriches have always been thought as being stupid. And spending time with them, you understand that they are not that stupid. They have emotions like any animals. And, if you treat them right, they will respond right. There's some people on the farm, some females just couldn't stand them. And I'm thinking they must have done something to that female. She remembers. So you have bad news, I'm not coming close to you. So for me, it was quite amazing. But yeah, I think it's a mind shift into not treating those animals like birds, stupid birds. Respect them, and they will show you the respect you deserve as well.
Wow. It's like this ostrich thing is so exciting. And there is a follow-up question on the aspect of the 4 to 6 weeks when you think that the maternal immunity, fades off. There is a question here that, do you think maybe the use of nutritional manipulation can help to boost the immune system of the chicks, or maybe by feeding the mothers with some stuff before laying or during the laying process? What do you think?
I'm not a nutrition expert by any stretch of the imagination, but I guess it's possible. And sometimes we do that, especially for the ones that were not part of our experiment, where we give them some vitamins, comes 4 weeks of age, just to see if it actually helps a little bit. It might to some extent, but it's expensive. So, I mean, if you can, by just spending more time with them, and making sure they're okay, get to the same percentage of survival, then it might be worth just I'm not really keen of doing any supplements if it's not needed. That's just my personal feeling about it, especially if you can get away with it. And but it's been used sometimes when you see the chicks are a little bit down, we give them some vitamins, and it seems to help to some extent.
Okay. Well, thank you so much. There are still questions here that I have.
Sure.
Yeah, I think, yeah, when you talked about the handlers, the ostriches getting used to a particular handler, and of course, this have implication with the management system. Like you said, what if you are not around? Does that mean that the female animal would not be, will not allow others to inseminate her? So how can this also, because it's a big challenge, of course, you may not be there every time, and you may also at times have handlers that maybe they are sick or need to travel or need to do other things somewhere else. How can we try to work on this so that the welfare of the animal will not be impaired, and it will also make them feel a bit more comfortable to accept other people?
I think it's a matter of also getting more people involved with the animals and explaining to them why it's important not to to act a certain way with the bird, and not just, I mean, my team was very small, unfortunately, but we know also that some people, because of a relatively calm behavior, we know they work better with chicks, for instance, while other person, just because of their character, and I'm not saying that in a bad way, they are more efficient when it comes to handle bigger birds. But when it comes to the chicks, because they're so sensitive, you select a range of people that can actually step in when it's needed. And for instance, now I'm not really anymore on the farm. I'm just supervising from a distance because I have a different job now. But I train my students, and over time that female got used to him. And now we have another person, a student that's going to start next year, but already started, and it's taking time, but they're switching back to someone else. So I think, unfortunately, at this stage, because we haven't, how can I say, fast-tracked the process of getting more and more docile animals, then it takes a little bit longer. But the selection at the beginning is very important. You know, we spend a lot of time looking at those animals and select the ones that are actually responding to us in a more positive way.
Yeah. I think there is a whole lot. You've really opened up a research area for people to, you know, there are lots of insights and things that are yet to be done and things that are yet to be understood, especially when it comes to ostrich behavior. I was amazed seeing the, you know, the male showing that the sexual behavior or the stamping of the feet, and it was so interesting for me. There is a question here in the chat box from Elitu Timitokwe. Said, great presentation. I would like to ask about the average lifespan of ostrich, and what is the ideal age most times that you do your research on them or something?
I'm not sure I understand the second part, but the first part, okay. You have to remember that when you are in a farming system, it's all about the animal being participating to the production system. So in our case, when they reach 10 years of age, we can see that the egg production and chick production starts to go down. So we're selecting against those birds, but we also have managed to select for birds that can start producing younger. On typical ostrich farm, the farmers will tell you that they can't really reproduce before 3 to 4 years of age. We have birds that are fully efficient at 2 years old. Not all of them, but many of them. But there's also ostrich farmers that will tell you that the best ostriches are anything between 15 to 33 years of age, and I doubt it strongly. I think it's because they see them, they might have been prime breeders when they were much younger, and because they are maintaining flock camps, they don't really know what's going on, and that's the problem. Trying to shift that idea that they can reproduce until 30 years of age. It's just not happening. And I had this conversation with breeders, and I said, you need to get rid of those birds. You can see them; they look sad, to be honest. So it's better to decrease the age range. In the wild, I think they can go also between 35 years, but I mean, it's different settings. They have different problems when they have to run for their lives. So yeah, I mean, for us, 10 years of age is the cutoff for breeding purposes, but you can also use those birds for foster parenting. Really good to foster chicks.
Oh, yeah. So they are good in fostering chicks, right?
Yeah. Not all of them. That also needs to be, really checked. Some birds are really good. Others are terrible. That we know as well.
But ostriches, do they also perform things like nesting behavior?
Yep. It's slightly different than small birds that they build their nest. Their nest is very basic. They basically dig a hole in the ground with the males usually. They go on the ground and then they push with the legs, and they create holes that could be easily 1 meter of diameter. So that's how they nest. Then the female comes and lay. When you are in a flock situation, there's several females that actually lay in that nest. So not just the eggs of one female.
What is the average clutch size before she starts incubating the egg?
It's anything between 20 to 30 eggs. Usually.
Wow.
Yeah. It's a
20
lot.
20
Yeah.
to 30 eggs.
Yeah.
Like in chickens, we are aware that it takes like 26 hours interval for each egg. So what is the interval like in ostriches?
They can lay every 2 days. Every 2 days. Yeah. Every 2 days, they usually have they usually lay for 10 days straight, and they take a break if you remove the eggs, and then they start again. They take 4 or 5 days off. Some females in our farm can actually carry on all the way through the breeding season.
Okay, there's a question that just came in.
Mm-hmm.
Please, how many species of ostriches are in existence? And which one of them do you carry your research on?
Mm-hmm.
And which species can you recommend for commercial production?
Okay. There's 3 breeds of ostriches. There's what we call the South African black ostrich, the Zimbabwean blue ostrich, and the Kenyan red ostrich. Now, we have the 3 subspecies on our farm, but the South African black ostriches have been domesticated for slightly longer, so they are easier to handle, first thing. They are a bit more habituated to the farming process, so in that sense, they will produce more chicks than the other 2 breeds. So if you start, I would not start with the blues or the reds, because they're really much more aggressive as well. The blues are a bit more skittish as well. But in terms of, if you go for meat production, the blues and the reds, because they are bigger, they would produce more meat and more skin as compared to the blacks. But we have been struggling with these 2 subspecies. So yeah, to the point that we started phasing them out because it was a bit too much trouble, really. But I know in Zimbabwe, they used to breed for these specific ostriches.
You talked about the blue, the red, the black. Does this have to do with the feather color or the skin color?
They really not really. The reds, yes, because they are first much bigger than the 2 others. They're taller, larger, and when the breeding season starts, their whole body turns red. That's the one you will see when you have documentary in the Masai Mara or in the Serengeti. The neck is red, the legs are completely red, so you really can see the difference with the 2 others. The Zimbabwean blue, they look a lot like the South African blacks, but they are thinner and slender, taller and thinner. And their feather quality is not really good. They really don't have good feathers. But they're very skittish as well, very skittish.
Well, thank you so much for this wonderful presentation. And yeah, I would also want to know a little bit about mate choice. If they are given the opportunity to choose, what does the female ostrich look out for to pick the male ostrich that she prefers?
Okay. So that's basically was the topic of my PhD long time ago. And they specifically look at what I focused on was the coloration of the feathers, right? And what we saw is that the brighter the plumage, specifically the black and white, the more attractive those males were for the females. So they were not necessarily laying more eggs, but the eggs that they were laying with, they were mating with those specific birds were bigger. And that has a huge importance because the egg weight is related to the chick weight, which is related to the survival of the chicks up to 1 month of age. And what I found out as well is that both coloration are an indication of the quality of the males in terms of how good he can raise the immune response. So all of that is interrelated. So that's how the ostrich male show their quality to the females, and that's what they select for, if they can select for. Because there's also a hierarchy, between females. But if given the choice, they will go for this very bright black and bright white males.
Yeah. But a final one, which is, are they monogamous or polygamous in nature?
Oh, no, they are promiscuous. They're not even polygamous. They're promiscuous.
Promiscuous.
Yeah, they have a favorite partner, but they also go to the neighbor. And females also will typically go to another male's territory, mate with him, lay eggs in his nest, and then back in her nest as well. So they're not putting all the eggs in the same basket, basically.
Yeah. But does that mean she will have to stay for a few days with this other male?
Not only if she is the dominant female for that specific male. Otherwise, she will just leave, and someone else is going to take care of those chicks for her.
Yeah, but how are you sure that the male ostrich is actually the one that fertilized the egg that she laid in this?
What we did is that we did genotyping for my PhD, so I knew where those chicks come from.
Wow.
So I had that's the graph that I showed you earlier. That's from genotyping.
So of course she doesn't take the chick from one father and gives to another father.
No.
She drops it there. Take care of.
She just drop them there. Yes.
This is quite exciting. Thank you so much. There is a last question in the chat box, and that will be all before we go for a 10-minute break. Are ostriches purely herbivorous, or can they be occasionally omnivorous?
Right. There's been a lot of discussion about that. They're technically herbivores, but ostriches are very, very, very curious. And I think if they eat like a snail or a small lizard, it's just because they peck at it and they just swallow it. Why I'm saying that is because I couldn't wear any jewelry or pins in my hair because they would go for it and swallow it. So yeah, this is not the most cleverest thing they can do. So like I said, lots of contention about that, but I don't believe they do it on purpose.
Okay. So with this, I say a very big thank you for being our first plenary speaker and for giving us insight into the world of ostrich behavior and welfare.